If you've ever walked into a store for something simple, like batteries or a specific size of shoes, and the shelf is empty, you've felt the pain of bad forecasting. And if you've ever wondered why a store has a mountain of products nobody seems to want, that's the other side of the same problem. Today's episode is about a national retail chain that lived in both extremes at once, and it was costing them tens of millions of dollars every year. This isn't a theory session. This is a real case. Traditional forecasting didn't fix it. Experience and intuition didn't fix it. Even common seasonality models didn't fix it. But intelligence did. And the result was a $42 million revenue recovery. So how did they do it, and what can you learn from it, even if you're not in retail? Let's get into it. Welcome back to the B.I channel. I'm your host, Nakel Nakima, and today we're staying grounded in a transformation story powered by business intelligence and modern predictive methods. With me is Stella Sinclair, Senior Vice President of Retail Intelligence at B.I.M Corporation, and someone who has spent years in the trenches of forecasting, inventory, operations, and what it really takes to make data useful.
Thanks, Nakel. I'm excited for this one because the story is bigger than one company. It shows what happens when leaders stop asking, "What do we think will happen?" and start asking, "What does the data say is happening right now and what's likely next?"
I want to set expectations for listeners. We're going to talk numbers and approach, but we're also going to talk about decisions, failure points, and what it looks like when an organization shifts from reactive planning to intelligence-driven planning. Stella, start us at the beginning. What was the situation and how bad was it?
This was a large retail chain, around 600 stores across the U.S., selling a mix of everyday essentials and seasonal products. On paper, they looked stable. In reality, they were leaking money through operational chaos. They had an 18% stockout rate, meaning almost 1 out of 5 times a customer wanted something that wasn't available. They also had a 22% overstock rate, so nearly a quarter of inventory was sitting too long, tying up cash, and eventually getting discounted or written down. When we quantified the impact, it came out to about $42 million a year in lost revenue. And that number didn't even fully capture the long-term damage. Customers losing trust, switching stores, bad online reviews, store teams constantly improvising.
That combination is brutal. Stockouts hurt sales now, overstocks hurt margin later, and both of them create a sense that the business doesn't know what it's doing. So what were they using for forecasting at the time? Paint the picture.
It was the classic setup a lot of retailers still have. They relied heavily on spreadsheets. They used historical averages and last-year comparisons. There were planners and district leaders making judgment calls based on experience, what you might call merchant intuition. And there were some seasonality rules. For example, certain categories get a bump in summer, certain snacks spike around holidays, that kind of thing. But everything was largely static. The world changed faster than their system could adapt.
Let's dig into that, because a listener might think, how can a big chain still be running forecasting like that? But it's more common than people admit. Why exactly did the traditional approach fail here? What was it missing?
Traditional forecasting assumes demand behaves in a relatively stable pattern. It basically says, if we've seen this trend before and nothing major changes, then next week should look like last week. But modern retail demand is influenced by a messy set of real-time forces. Weather changes demand, sometimes dramatically. Social trends change demand overnight. Competitor promotions can pull customers away instantly. Local events, sporting events, festivals, even road construction can change traffic patterns. And then you add online behavior. People will browse online, compare prices, see what's trending on social media, and then show up in store expecting availability. Demand is now dynamic, volatile, and nonlinear.
You just used an important word, nonlinear, meaning it's not a smooth, predictable curve. Can spike, stall, flip directions.
Exactly. And spreadsheets and static seasonality models struggle with that kind of reality. Their system couldn't respond fast enough, couldn't localize accurately enough, and couldn't detect when demand was being pulled by something outside the usual pattern.
So the organization is facing this constant whiplash. Store teams are getting yelled at for empty shelves. Finance is frustrated because inventory is bloated. Customers are annoyed. And leadership is asking, Why can't we just forecast better? Stella, when you came in, how did you define the goal? Was it just better forecasts? Or something more specific?
We framed it as building an intelligent system, not just producing a forecast number. A forecast is a snapshot. Intelligence is a living capability. We wanted 3 outcomes. First, detect demand shifts early, while there's still time to respond. Second, forecast at the right level of detail, store level and micro-region, not just national averages. Third, help leaders test decisions before committing expensive mistakes.
That's a big shift. From predicting to sensing, adapting, and simulating. Walk us through the solution you built.
We designed it as a 3-layer system. Each layer solved a different part of the problem, and together they created a feedback loop that kept improving over time.
Let's start with Layer 1.
Layer 1 was real-time demand intelligence. The core issue was that their view of demand was narrow, mostly point-of-sale history. So we unified more signals to create a real-time picture of what customers were likely to do next. We brought together POS data from stores, online browsing behavior, social sentiment signals, weather forecasts, competitor pricing and promotions were available, and local event calendars.
So not just what people bought, but what they looked at, what they talked about, and what conditions were surrounding them.
Yes, point-of-sale data is like reading the end of a story. It tells you what happened after the decision. But browsing and other signals can be earlier indicators. What customers are leaning toward before the purchase.
What's an example of how that changes things? Because some people hear social sentiment and think it's vague.
A practical example, a sudden viral trend can spike demand for a specific product category. If you wait for POS data to show the spike, you're already behind. But if you pick up early indicators, searches, clicks, mentions, you can pre-position inventory before shelves go empty.
So Layer 1 is about seeing demand as it forms, not after it hits you. Now Layer 2, the forecasting engine itself.
Layer 2 was the AI-powered forecasting engine. We used machine learning models that could incorporate all those signals and adjust quickly as conditions changed. We also used anomaly detection to tell the difference between a normal variation and a real demand shift. That matters because you don't want to chase noise. You want to respond to meaningful changes. Then we added micro-regional forecasting. Instead of grouping stores too broadly, we modeled demand at a much more local level, because what sells in one zip code can behave totally differently 20 miles away.
That local detail is huge. A national average can look fine while stores are either empty or drowning in product.
Exactly. And we also introduced elasticity modeling, so the system could estimate how demand might change when prices change, or when a competitor runs a promotion.
So the forecast isn't just, we think we'll sell 100. It becomes, if you price at this level and your competitor does that, and the weather looks like this, here's the likely range.
That's the idea, and the results were clear. Forecast accuracy moved from around 63% to 92%.
That's not a small improvement. That's the difference between steady operations and constant firefighting. Now Layer 3 is where I think it gets really forward-looking. Simulation intelligence. Explain what that means in this case.
Layer 3 was the what-if layer. Retail leadership makes decisions that have consequences across the supply chain. Promotions, price changes, assortment adjustments, allocation plans. The problem is that many organizations make those decisions and then hope it works out. We gave them the ability to simulate scenarios before committing. What happens if a supplier delay hits? What if we promote an item for 2 weeks instead of 1? What if weather patterns shift? What if a store has space constraints and can't physically hold the inventory we're sending?
So instead of guessing, they can run the decision through a model and see the impact on stockouts, overstocks, revenue, and even operations.
Yes, and it changes the tone of leadership conversations. It's no longer a debate of opinions. It becomes a structured discussion about scenarios, trade-offs, and probabilities.
Let's pause there because that's a subtle cultural shift. A lot of organizations are used to the loudest voice winning or the most senior person's instinct driving the plan. When you introduce simulation, it's like saying, we can test it first. It's hard to argue with that.
It's a different kind of accountability. It doesn't guarantee perfection, but it reduces avoidable mistakes. When you can test decisions, you stop repeating the same failures.
Okay, now take us to implementation reality. It's one thing to describe a 3-layer system. It's another thing to ship it into a 600-store business. What were the practical moves that made it work?
A few things mattered. First, we didn't treat this as data science in a corner. The business, merchandising, supply chain, store ops, had to be involved early, so the system matched how decisions are actually made. Second, we focused on data unification and trust. If leaders don't trust the inputs, they won't trust the outputs. So we built clear definitions, consistent metrics, and transparency around where signals came from. Third, we operationalized it. Forecasting isn't valuable if it stays inside a dashboard. It needs to drive replenishment, allocation, and promotion planning on a defined cadence.
That's such an important point. People talk about dashboards like they're the end goal. But dashboards are just windows. The question is, do you change behavior because of what you're seeing? So what happened after the system was in place? Give us the scoreboard.
The impact was dramatic. Stockouts dropped from 18% down to 4%. Overstock decreased from 22% down to 7%. Inventory turnover improved by 31%. And the headline result: they recovered $42 million in revenue that had been effectively slipping through the cracks.
Recovered is a powerful word. This wasn't a new product line. It wasn't a lucky market swing. It was money they were already in position to earn but couldn't because execution wasn't aligned with demand.
That's right. And customer satisfaction rose by 19 points because customers experienced the business differently. Better availability, fewer disappointments, more consistency.
And that's the part people underestimate. When shelves are consistently stocked with what people want, customers don't call it forecasting success. They call it, "This store is reliable." Let's unpack the why behind those improvements. What were the main drivers? Was it the accuracy increase, the speed, the localization, or the simulation?
It was the combination. Accuracy helped, but so did responsiveness. The system could adapt quickly when something changed. And because it was localized, it didn't treat the whole country as one consumer. Simulation helped leadership stop making the same expensive choices repeatedly. Instead of rolling out a promotion broadly and hoping stores could handle it, they could test the likely outcome and adjust the plan.
Now I want to make this episode useful beyond retail, because not everyone listening runs 600 stores. But many listeners deal with demand uncertainty, whether it's manufacturing, services, staffing, logistics, even digital products. What are the lessons here that transfer to other industries?
There are 3 big lessons. First, intelligence beats intuition. Experience matters, but markets move too fast for gut-based decision-making to be the primary system. Use intuition as a hypothesis generator, not the final answer. Second, real-time data is a competitive advantage now. A monthly static report or a weekly dashboard that doesn't update quickly enough becomes a history lesson. You need signals that reflect what's happening now, not what happened weeks ago. Third, simulation is the future of leadership. The best leaders will be the ones who can test decisions, compare scenarios, and make trade-offs consciously rather than learning only after the fact.
I love that framing. Leadership as scenario navigation. You're not pretending certainty. You're choosing the best path among possibilities. Let's challenge something for a second. Some skeptics hear AI forecasting and think it's a black box. They worry the business stops understanding decisions. How do you handle that concern?
It's a valid concern. The answer is governance and transparency. You can use advanced models while still showing the factors influencing outcomes, tracking performance, and validating results over time. We also didn't remove humans from the loop. We upgraded their role. Instead of manually creating forecasts, they became decision makers and exception managers, focused on strategy, unusual situations, and improvement.
So humans move up the value chain. Less time doing repetitive mechanics, more time thinking critically.
Exactly. And when the system flags an anomaly, a human can ask, is this real? What's driving it? Do we need a response? That partnership is where the value is.
Let's talk about the listeners who want to take action. If someone is in a business where demand is unpredictable and inventory or capacity planning is painful, what's the first step? Not the shiny tech stack. What's step 1?
Step 1 is being honest about the cost of the current system. Quantify what stockouts, overstocks, missed demand, rush shipping, markdowns, and poor service levels are costing you. When you see the number, it changes the urgency. Then step 2 is identifying which signals you're ignoring that could improve decisions. For some businesses, it's weather. For others, it's web behavior. For others, it's competitor actions, regional events, or supply variability.
And step 3?
Step 3 is building the bridge into operations. Don't just create insights, connect them to the decisions that move money, purchasing, replenishment, staffing, production scheduling, pricing, promotions. Intelligence needs an execution path.
That's the theme of this whole episode. Intelligence that doesn't move decisions is just information. Before we wrap, I want to come back to the headline, $42 million recovered. If you had to explain in one sentence why they got that back, what would you say?
They stopped treating demand as a static prediction problem and started treating it as a real-time intelligence problem. Then they embedded that intelligence into daily decisions.
That's it right there. Stella, thanks for breaking this down. It's the kind of case study people remember because it's not magic. It's disciplined intelligence, better signals, better models, better testing, and better execution.
Thanks, Nakel. And if listeners take one thing away, it's that forecasting isn't just a planning function. It's a competitive weapon when it's done with intelligence.
That's going to do it for today's episode of the BI channel. If this story made you rethink how your organization plans, forecasts, or reacts to change, keep that thought. Ask yourself, where are we still relying on averages and intuition when the environment is clearly moving in real time? And if you want more case study episodes like this, real problems, real numbers, real transformations, stay with us. Until next time, I'm Nakel Nakima.
Disclaimer: all companies, roles, and characters in this case study are fictional and used for educational purposes only. Any resemblance to real entities is coincidental.